Hi, I'm making this short video just to talk you through um, sort of a multi-step biology maths question. So it's the kind of question that you might come across in the exam, and if maths isn't really your thing, you might find quite challenging. So what I urge you to do is first to open up the question and to try to do the question yourself first. Okay, so the question is about ATP and water. So I'm just going to read through the question here. Hydrolysis of ATP is catalyzed by the enzyme ATP hydrolase. The student investigated the effect of ATP concentration on the activity of ATP hydrolase. She used shortening of strips of muscle tissue caused by contraction of evidence that ATP was being hydrolyzed. She took 4 slides, A, B, C, and D, and added strips of muscle tissue of the same length to each slide. She then added the same volume of ATP solutions of different concentrations to the 4 slides and left each slide for 5 minutes. She then recorded the final length of each strip of muscle tissue. So these are the results. So you can see that you've got 4 slides, A, B, C, and D. Then you've got a concentration of ATP solution added to the slide. That's in times 10 to the power of minus 6 moles per decimeter cubed. So it's a moles per decimeter cubed concentration, but in times 10 to the minus 6. Okay, so you can see that that concentration is increasing. And then final length of muscle tissue after 5 minutes, that's measured in millimeters. And you can see here that it goes from 36, 31, 29, 26. So that's decreasing. Okay, so there's a couple of questions about the examination, the experimental technique, and then describe and explain the pattern shown in the data. So I'll let you do that. What I'm interested in here is the maths question. So it says the hydrolysis of 1 mole per decimeter cubed, hydrolysis of 1 decimeter cubed of a 1 mole per decimeter cubed solution of ATP releases 30,500 joules of energy. Okay, so that's how much 1 decimeter cubed. Let's remind ourselves of a decimeter cubed. That is 1 liter. So 1 liter of 1 mole per decimeter cubed solution of ATP releases 30,500 joules of energy. Okay. 60% of the energy released during the hydrolysis of 1 moles per decimeter cubed is released as heat. Okay, so 60% of this is released as heat. In our investigation, the student added 0.05 centimeters cubed of ATP solution to slide D. So we're looking at slide D. Okay. And the question we're being asked is calculate the energy available. So calculate energy available for contraction on slide D. Okay. So that's the information that we have. We can see we've got quite a lot going on here. We've got some decimeters cubed. We've got some joules. We've got moles per decimeter cubed. We've got percentages. We've got centimeters cubed. We're being asked to calculate energy. So if we're calculating energy, we should end up with an answer in joules or kilojoules. Let's go to slide number D in our table because we're being asked about slide D. And it says in slide D, the concentration of ATP solution on slide D is 8 times by 10 to the power of minus 6. And that's moles per decimeter cubed. All right. So I think that that's all of the information that we need for this particular investigation. Okay, I think to do the actual calculation, I think that that's all we need. All right. So we've got to think, where do we start with this? All right, so we are looking at slide number D. So here is slide D, and slide D has got 8 moles per decimeter cubed present on it. I'm just trying to see, can you see this? I'm not quite convinced you can see the whole thing. All right, so let's see. Okay, all right. So 8 moles per decimeter cubed. Let's hope that I can maintain this now. All right, so I think the first thing that we should do is we should use the information that we have here. We know that 1 decimeter cubed of 1 mole per decimeter cubed of ATP makes 30,500 joules of energy. So it would be a good idea if we worked out how many joules of energy they are in 1 litre of D. So let's work out how much energy there is in 1 decimeter cubed of D. Okay, so if we're thinking of 1 decimeter cubed, we can say that, okay, I'm going to scroll, I'm going to have to come down now. So we can say that we know that there are 30,500 joules in 1 mole per decimeter cubed. Okay, and that's for 1 decimeter cubed of it. So for 1 litre of it, we know that there are 30,000 joules. And we want to know how many joules there are in we want to know how many joules there are in this concentration, D's concentration, because this is the concentration of D. Okay, so this is what we call our stock solution. This is D. So how many joules are there in that concentration? Okay, and so in order to do that, I would sort of turn that into an equation. So I would have x over 30,500 is equal to 8 times 10 to the power of minus 6 over 1. And then I would simply multiply this side by 30,500 and multiply this side by 30,500. Okay. And I would hopefully, I'd cancel that, and I would end up with x is equal to 8 times by 10 to the power of minus 6 multiplied by 30,500. And so it would give me 0.244 joules in 1 litre. Okay. So that is how many joules of energy there are in 1 decimeter cubed or 1 litre of D. Okay, in 1 litre. But they don't want it in 1. We're not talking about 1 litre. We're talking about, if we go back up here, can you see? No, you can't see that, so I'll just get up a tiny bit. We are looking at 0.05 centimeters cubed. So now we've got to convert that to centimeters cubed. So here we've got it in a litre. We need to now find out how much there is going to be in 0.05 centimeters cubed. So we need to do something about the units. Okay, so how much energy in 0.05 centimeters cubed? Well, we know that there is oops, oh dear, lost the camera. Pause. So units are an issue here. So we need to now convert from decimeters cubed to centimeters cubed. So we've already said that 1 decimeter cubed, we know, is essentially 1 litre. Okay, we know that. We should also know that 1 centimeter cubed is equal to 1 milliliter. We should also know that there is a conversion factor of 1,000 because there are 1,000 milliliters in a litre. That means that there are 1,000 centimeters cubed in a decimeter cubed. So 1 decimeter cubed is equal to 1,000 centimeter cubed, in the same way as 1 litre is equal to 1,000 milliliters. Okay, so if 1 decimeter cubed is equal to 1,000 centimeters cubed, it means that there is 0.244 joules of energy in 1,000 centimeters cubed of D. So the question we're asking is, how many joules are there in 0.05 centimeters cubed of D? So again, if I want to turn that into an equation, I'll do exactly what I just did before, and hopefully that sort of fits in with your GCSE maths. I say x is equal to 0.05 divided by 0.244 divided by 1,000. Again, I'll multiply this side over here, 0.244. So multiply this side by 0.244. So I should end up with x being equal to a value of 1.22 times by 10 to the minus 5 joules in 0.05 centimeters cubed of D. Okay, so we still haven't got to the end of the question, right? We still haven't got to the end of the question. We now need to use the information that was given to us at the beginning, where they said that 60% of the energy is lost as heat. So if we have got 1.22 times 10 to the minus 5 joules of energy, 60% of that is lost as heat. Okay, so that means that 40% is useful. 40% is used in the contraction. So 40% of 1.22 times by 10 to the minus 5 joules is used in contraction. Okay, so that means I say 40% is 0.4. 0.4 times by 1.22 times by 10 to the power of minus 5 joules is equal to 0.488 times by 10 to the minus 5 joules. And then I want to convert that to a better number, 4.88 times by 10 to the minus 6 joules, okay? Because I multiply this by 10, so I divide that by 10 to keep it the same number, okay? All right. You could have also said here, if you're using your calculator, you could have just said 40% multiplied by 1.22 times by 10 to the minus 5 joules. So just to review what we've had to do in this calculation, which is what makes it challenging for some people. The first thing is mostly ratio and proportion that you are using here with a little bit of conversion of units, okay? So the first thing that you have done is you have used ratio and proportion to calculate how many joules there are in 1 decimeter cubed of solution D. So that's the first thing you've done. The second thing you've done is taken that value and you have calculated here that how much energy there is in, oops, oh yeah, here we are, how much energy there is in 0.05 centimeters cubed. So here you had to do a little bit of unit conversion, okay? So you had to do your unit conversion over here. So be able to convert between centimeters cubed and decimeters cubed. And then the last thing that you needed to do was to take into account the fact that only 40% of the energy is used. Okay, so it's only 3 marks, but there's a lot in there. So it's just worth practicing these sorts of sums to get them right.